All right, here is the second part of the video for section 3.3. Okay, quadratic functions and their properties. Okay, these are the learning objectives. Graph a quadratic function using its vertex, the axis, and then the intercepts. Okay, find a quadratic function given its vectors and 1 point on it. In other words, you're going backwards, you have the function, you get a vertex and the axis. Okay, here you are given the vertex and then a point and to find the equation or the quadratic function. And then we also talk about the maximum and minimum values. Okay, but before we go further, any further, let me explain something here for the what do you call it, regarding the quadratic function, a quadratic formula. All right. Now remember, if you have the function, the quadratic function is of this form: as squared plus bs plus c. All right. Now, if you want to solve this equation, this becomes a quadratic equation. Set it to 0. That is when you can use the quadratic function, formula. Now, this formula is derived by completing the squares. If I complete the squares, okay, complete the squares of this original function that we did, okay, then we set it to 0, we get this quadratic function. So the roots or the solution are x is equal to minus b plus or minus the square root of bs squared minus 4ac, all divided by what? 2a. Now, when we pick this expression here, okay, what is under the radical sign? We give it a special name. We call it what? Discriminant. Okay, we call it discriminant. Now, the roots, the quadratic equation, this one that we have here, if you set it to 0, can have 3 possibilities, 3 roots or 3 solutions, 3 types of solutions, and that would depend on this discriminant. Okay, so when would this happen? When you want to find the root, which is the same as the x-intercepts. Whenever you want to find the x-intercepts, okay, that is when we set the equation to 0. When you set it to 0, that is you can use the discriminant to determine how many solutions, whether to have a solution, either 1 or 2 or no solution, because in other words, it's not a real number. Okay, so here are what we have. Okay, finding the x-intercepts. Find the x-intercept, meaning that we are setting the equation. Okay, we are setting the ax squared plus bx plus what? Plus c equal to 0. So when we set that to 0, okay, that is when we find out what the x-intercept. In this case, your f of x, we set it to 0 because the f of x is 0 when you want to find the x-intercepts. Now, like I said, the solution will depend on what? The discriminant. So if the discriminant is positive, it means that the graph has 2 distinct what? X-intercepts, or in other words, x solution, 2 distinct what? Solutions, so that it crosses the x-axis in 2 places. Now, if the discriminant is equal to 0, all right, if you calculate the discriminant is equal to 0, it means that the graph has what? It touches the what? X-axis at the vertex, okay, at its vertex. Now, if it is negative, then it doesn't have what? Has no x-intercepts. That means it's either it doesn't cross or it doesn't what? It doesn't touch it. Because if it's the radical, under the radical sign is the value there is negative, then it has no real solution. And that means it doesn't touch it, either hanging, sometimes either a shift up or down, okay, depending on the value of what? Of the k. All right, so this is what's happening. Okay, the figures below illustrate the possibilities for the parabola, okay, that has what? Concave up. Okay, that are all concave up. So if the vectors, you know, is what? X is equal to h, which is that, all right? The first one, looking at this graph. And then this is what? X-intercept. That means that the discriminant is what? If you calculate the discriminant, it's going to be what? Greater than 0. In other words, that's why you have what? 2 solutions, which are what? Your x-intercepts. Now, if it is equal to what? 0, if it's equal to 0, then the vectors, of course, will touch the what? The x-axis, If it is concave down, it's going to be something like that. Okay. And so that is this another situation. The axis of symmetry is still the same. It doesn't change. S is equal to minus B over 2A. Okay. Now, if it is negative, if the discriminant is negative, then there's no x-intercept. So that means it's going to hug up or anywhere in the graph, whether it's concave up or concave down. All right. So we're going to take one example, which is example number 3 on the slide. Say graphing a quadratic function using x vectors, the axis, and then what the intercepts. Okay, so we want to graph that. Then we want to find the domain and the range of that, because we will determine where f is what increasing or where is it decreasing, depending on whether it's concave up or concave down. All right, and then determine where it is greater than 0. The f of x is greater than 0, or where it is what is less than 0. Then we also, add what the maximum or minimum what value. All right, and we are going to use the graph to find that, and also use the formulas to calculate the maximum or minimum values. Then we will see and compare the two solutions. Okay, which we expect them to be the same. All right, so here we go. This is our function. All right, f of x is equal to negative 2x plus 4x plus what? Plus 2. Okay, it said A is negative 2, B is 4, and then C is what? Is 2. All right, now, is it going to be concave up or concave down? Depends on what your A. All right, your A is what? Negative, so is what? It's going to be what? Concave down. All right, then what is the x coordinate of what? Of the point, of the vertex. What would be s coordinate and what's the y coordinate? So what's the s coordinate of the vectors is what? It is f of what? Minus b over what? 2a. Okay, so let's calculate the minus b over 2a. Okay, minus b over what? 2a. This is actually your h. Okay, 2 minus b, so that's minus 4, divided by what? 2 times a is what? Negative 2. All right, so you get minus 4 over what? Over negative 4, and that is equal to 1. So this expression here is actually f of 4. Sorry, just the h, sorry. Okay, this is just what h, your x vectors is what? Is the h, and that's what we got. So h in this case is what? It's just 1. Okay, that's the s coordinate of the point, because the vectors is of what? H and then k. Then the y coordinate is when we substitute. Remember, this is the same as f of what? Minus b over 2a. And so f of 1 is actually minus 2 times 1. We substitute into the original equation, f of x, then plus 4 times 1 plus what? Plus 2. Okay, let's evaluate that. Okay. So when we evaluate that, we have what? We have, if you evaluate that, you have what? This is 2. So that's a minus 2 plus 4. Okay. And then my plus what? Plus 2. So that is equal to 4. So therefore, what is your vertex? Okay. The vertex is going to have the coordinates what? 1, which is from that, and then what? And this 4. All right. Okay. So we have that. Okay. The vectors is equal to that. Now, let us continue. Okay. What's the axis of symmetry? The axis of symmetry is a line what? S is equal to the h. Okay. It is always s equal to what? The h. And again, your h is what? Minus b over what? 2a. All right. Now, let's continue. Now, what is the y coordinate? We want to find the vectors. Part A says find the concave up, or we know it's concave up, sorry, concave down. The y coordinate or y axis, y intercept, sorry. Y intercept is what? F of 0. Okay. Okay. Well, how do we get that? The f of x is equal to minus 2x squared plus 4x plus 2. So what is f of 0? Okay, that is going to be 0 plus 2, and that's where we got a 2 from. So the y-intercept at the coordinates what? 0, 2. Then what is the x-intercept? That's when we set this to 0. Now let's try to, there are a couple of ways we can do this. Okay, we can try to factor this, or we use a quadratic formula. All right. Now, if I want to factor this, you cannot factor this easily. All right. Okay. You have, let's try it here. You have a minus 2x squared plus 4x plus 2. Okay. If you set this to 0, it's the same as dividing through by what? Say negative what? Negative 2. And that gives me x squared minus 2x minus 1 equals 0. So let's try to factor this. If we put x there and put x there. Okay, 1 times minus 1 is minus 1. Okay, what are the factors of this? So that when you add, you get minus 2. You need to get minus 1 and minus 1. Okay, so that, but this doesn't, 1 has to be positive. So negative 1 times negative positive 1 is negative 1. When you add, you get 0, but you need 2. So you cannot factor this. We can't. Okay, we can't factor this. So we use a quadratic formula. All right, we're going to use a quadratic formula for this, which just means that x, this equation will have the roots minus b, okay, plus or minus the square root of what? B squared minus 4ac divided by what? Divided by 2a. Okay, now let's use the discriminant and see what happens. Okay, if you have b squared minus 4ac, what is this value? Okay, b squared is what? B is 4, so squared. All right, minus 4 times negative 2 times what? 2. This gives me 16. All right, 16 plus what? 16. Okay, which is definitely what? 32 is greater than 0. So it means that the equation here will have what? 2 distinct what? Roots or solutions. All right, so here, what is my b? My b is what? 4, so the minus 4 plus or minus the square root of 4 squared minus 4 times, okay, 4 times 2 or minus 2, that's a. And then c is what? C is 2. Okay, then divided by 2 times what? A, which is minus what? Minus that. So this is minus 4 plus or minus, okay, we just found the discriminant, which is what? 32. Okay, everything divided by what? Minus what? Minus 4. Well, this is equal to minus 4 plus or minus 32 is the same as what? 8 times what? 8 times, that's 8 times 4 or 4 times or 16 times 2. Okay, 16 times 2, which will give me what? If you have square root of what? 32, this is the same as what? 4 root 2. Because you get 16 times 2, so square root of 16 is 4, and then root 2. So this is what? 4 root 2 divided by minus 4. Okay, so if you divide each of them, okay, you have minus 4 over minus 4, then plus or minus, then 4 square root of 2 over minus 4. Now, what would that gives me? This gives me 1 plus or minus the square root of 2. Okay, this 4 will cancel, and this is 1. So there are 2 points there. The x-intercepts are, you have for x is equal to 1 plus square root of 2, and then 1 minus square root of 2. Now, approximately, okay, so that you get to know, you can use a calculator, but you know, approximately this value is what? Minus 0.41. And that value is what? 2.41. Okay, so we have the y-intercepts. We have the what? The x-intercepts, all right? Which are these values? Okay, so the points, the x-intercepts should be 1, sorry, it will be 1 minus square root of 2, 0, and the other one is what? 1 plus square root of 2, 0. And approximately values are given there. All right. So now we want to use this to graph the what? This function. We know the x-intercepts, we know the y-intercept, we know the vertex, okay? We know the axis of our symmetry, all right? Now let's put all this together. The vertex, all right? This is the vertex. The vertex has the coordinates, okay? It is 1, 4, okay? The axis of symmetry is what? X is equal to 1. And then we know that the y-intercept is what? 0 or 2. Okay, x-intercepts are, they will just come to 1 plus square root of 2 comma 0. And then this is what? 1 minus square root of 2 comma 1, 0. Now, how do we use this to graph? Well, I'm going to draw my axis here. Okay. All right. So this curve is 1, 2. There's a 1, 2, 3, 4. Okay, we know that this one is concave up also. So concave down, concave forward down. It opens downwards, okay? And then we have that. This is x axis, and that's a y axis. All right, good. 1 and 2 also there. Now let's plot these points, okay? The y-intercept is this point, okay? Let me change the color. This is the y-intercept, okay? Then it is concave up. We have the vertex is what? 1, 4, which is this part. So it's concave down. So it's going to go like that at that point. Okay. The axis of symmetry, it passes through the 1. The x-intercept is somewhere there. And then y-intercept is somewhere there. Okay. So if we join this, we're going to have this just part of the graph. But the axis of symmetry passes through that. Passes through 1. And this is what x is equal to 1. So we can use this to find the other point. All right. Okay. This point is what? 0, 2. Okay. This distance is a line. It's a axis. So it's like a mirror. So it's a reflection. And then that point will be somewhere there. Okay. What will be the coordinates of this point? It'd be the x coordinates, y coordinate will be the same. The x coordinate, this is 1. This is what? This is 2. So we have this point, and then additional point, we should be able to what? To graph this what? The parabola. Okay, so that's why we have additional point I called what? 2, 2. All right, so the question is B, what's the domain of this function? Domain is what? All real numbers, or we can say that is from negative infinity to positive what? Infinity. Okay, and then based on this graph, what's the range? What's the range? Okay, this is 4. This the vectors is 1, 4, like that. So the range is what? It's everything from negative infinity to what? To 4. All right, and that gives me that. Okay, now part C says that we should find whether it's what? Increasing or decreasing. So this is the graph. Here's nicer. This is the graph of the parabola. Okay, which is, we got this. This is a graph of the parabola there. Now, okay, so if you have that, where is it increasing or decreasing? Okay, before up to this point, all right, it is increasing from negative infinity to x. We are looking at the x values, okay, to 1. And then it decreases from that otherwise. Okay, so it decreases from negative infinity to 1. Remember, I prefer that using parentheses. My MATLAB will accept whether brackets or not. So if for consistency, from negative infinity to 1 using parentheses. All right, but here we can use the close, which is acceptable for this this class. All right, and then it decreases what otherwise. All right, now the fourth question is that D said that we should find where f of x is what is greater than 0. That means it is above above the what? The x-axis. And then where is less than 0 is what? Below the x-axis. Okay, so we are looking for what? The x values where it is above the the x-axis. This is your x-axis is above, okay, this portion. Okay, so when x is between, okay, between these values, it is what? It is above it. And then when it is, if it is what? To the left of that, okay, it is below the what? The x-axis. Okay, so what is that? So what are the x values? So where it is above, okay, for where f of x is greater than 0, are there's the x values are what? When it's actually between these two. So we can use the what? When it's between the 1 minus square root of 2, okay, to what? To 1 plus the square root of what? 2. So when x values are between these values, it is what? It is above. Okay, or you can say that when x, this happens when x values are between what? 1 minus square root of 2 and 1 plus the square root of 2. Now, actually, this is, we said this is what? 2.41 approximately. And that is what? Negative 0. What? Is equal to negative 0.41 approximately. Okay. And then it is below, okay. F is what? Below x-axis when x is, okay, from negative infinity, from minus infinity, okay, to the value, which is the minus 0.41, and it is what? Above, that is what? 2.41 to what? To positive infinity. All these are what? X values. All right. Now, maximum and minimum. Okay, maximum from the graph. Okay, so you're looking at it from the graph. Okay, let's go back. Okay, from the graph. First, we want to get a solution. Okay, from the graph. Okay, from the graph. This is, we know that A is what? Negative. So it is what? Concave up. Sorry, concave down. It's concave down. All right. So it has a maximum value. So the maximum value is what? Is what? The vectors there, which is what? Which is 4. It occurs at what? X is equal to 1. Okay. So it has a maximum, the minimum, so maximum value is because it's what? It's concave up. Now we want to use the formulas, okay, to find whether we'll get the same thing. All right. Now, what is the function again? Okay. The function f of x is what? Minus 2x squared plus 4x plus what? Was it? Think of plus, was plus 2. Okay. Let me go back and check, making sure that, I think there was a typo there. The function, yeah, it was plus 2. Yeah, it was plus 2. I don't know where the plus 3 came from. All right. So there's a typo in the graph. Okay, this value here supposed to be what? Supposed to be 2. So take note of that. Okay, let's no. Okay, so this is plus 2. This value here should be what? Should be 2. All right. So if I use the formula, we know that the maximum, okay, maximum value, okay, occurs at what? At the vertex. It occurs at the vertex, all right? Where the vertex is what? Which is going to be f of what? Minus b over what? 2a. We evaluate the function at that point, okay? The vertex has the y coordinate. In other words, this is the what? The y coordinate. Is the y coordinate. Okay, so let's go to the next slide and then we show that. So the y coordinate of vectors of the vertex, okay, is going to be f of what? Minus b over what? 2a. All right, so for the function, which is minus 2a squared plus 4x plus 2, okay, your a again is what? Minus 2, your b is 4, and your c is also what? Is 2. Okay, so when you do this, what is f of what? F of what do you call it? F of 1 basically just minus what? 4 over 2 times minus 2. Okay, this will give me f of what? F of 1. So let's plug that in. You have into the function that is minus 2 times 1 squared plus 4 times 1 then plus 2. So that gives me minus 2 plus 4 then plus what? Plus 2. That's what we have 4. Okay, so you see that the maximum value is what? Is still what? Is 4. That is the same as from the graph. All right, so now the question is that if I have the vectors, okay, and a point, how am I going to get a quadratic function? All right, so that's the last example. Say that the vectors is what? Has a coordinates hk, and then they give me additional point. I should be able to get what? This function. Well, the vectors we put in this form, and we can obtain them by what? For the quadratic function. Function. Pretty much easy. All right. So here's an example. So determine the what? The quadratic function whose vertex is what? Is -3, -7, and whose what? Y-intercept is that. Now y-intercept, don't forget, is what? 0 what? 0, 2. It means when y is equal to 0, what is the function? All right, so the function is f of x. Since we have the vectors, is what? A, x minus h, all squared plus what? Plus k. So according to this, the vertex is giving us what? With the coordinates -3, -7. It means my h is what? -3, and my k is what? -7. All right, so if you plug it in, you have what? F of x is equal to the a, which we don't know, x minus -3, all squared, then plus k plus -7. Okay, which will give us what? A, x plus 3, all squared, -7. So the question is that, what is the a? How do we determine the value of what? Of the a? Well, we use a point. Use a point that it was given. Use the given point. Okay, the given point. Okay, there it says that the y equals 0. This is the point. So it means that in this case, my f of x is equal to what? Sorry. Okay, what does it mean to me? F of 0 is equal to what? Is equal to 2. F of 0 is equal to 2. So when x is 0, okay, y is what? Y is 2. So we use the point. That means that I have 2 is equal to a times x is 0, okay, plus 3 all squared, then minus what? 7. So let's find the a from here. So there's a, and then you have what? 3 squared minus 7, okay, which will give us what? 2 is equal to a times what? 9. 8 times 9 minus what? 7. So we add, okay, 7 to both sides. So you get 9 is equal to what? 9a. Okay, divide both sides by 9. And that means my A is equal to 1. Okay, so what is the quadratic function? Okay, so the quadratic function, okay, the quadratic function is the f of x is what? Given as a x minus h squared plus what? K. Now a is 1, so that is 1. We got x plus 3 all squared and then minus what? 7. Okay, which becomes f of x is equal to what? X plus 3 all squared minus 7. So that gives me the what? The quadratic what? Function. So you see that given the information, we are able to what? Get the quadratic what? Function. All right. So here is the end of this section. There's a video number 2. And then we'll see you very soon for the next one.